In a previous video, we talked about equations. We introduced the idea of what an equation is, how it compared to expressions, and we said in that video all equations go into two branches, one being a single variable. We also said that there were equations of two variables. In fact, we could extend this to two or more equations. And we said that there's a bunch of different equations that we study. Within the Algebra 1 playlist, we only talk about polynomials. And so before we can actually talk about linear equations, we need to talk about what a polynomial is. So we won't get into the formal definition until Algebra 2 and pre-calculus, but basically if we have this string of addition and subtraction of variables and numbers in this form, so assuming a, b, c, and d are real numbers, we define a polynomial as ax to the n plus bx to the n minus 1 plus c, and we say it's going to be equal to d. Well, so basically what this is saying is we take any term ax and we raise it to any number n, and it degrades. We say this is the leading coefficient of a polynomial, and basically what happens is it's going to go down all the way down to 0 power. So the c term is x to 0 power, which is 1. And we say it's going to be equal to some number. It could be equal to another polynomial, but what I'm getting at here is the simplest case of equations is a polynomial, is this form. And the basic of the basic is when n is equal to 1. But why is that? So let's just write this out, okay? So if we have ax to the n, so if n is equal to 1, that just gives us ax. Bx, and then 1 minus 1 is going to be 0. So that just gives us b. We don't care about any of this. It's going to be equal to d, a number d. And this is one form of a line. This is what we call a linear equation. The shape of this, if we were to graph it, which requires equations of two or more variables, would look like this. A line. What's going on now is we're going to have a bunch of equations. We're going to have equations of one variable to start with. That's the easiest case for us because we just have one variable to deal with. And it's going to be a linear equation because that's going to be the easiest way we handle things. Then we will move up to equations of two or more variables, and we'll talk about what that means later on. But let's talk about some notations. When we're going to solve some equations, if we have a single variable, we deal with sets. And basically it's just a set of numbers that we have in our solution. And so this could be any number, a and b, and we put brackets around here. This says, okay, these are solutions. This is what we call a solution set. Now, you can write it as x is equal or y is equal, but typically we write it in this notation, brackets a and b, and comma, c, d, any number as we go through. The reason being is just because it makes our work more organized. Now, if we end up getting no solutions that make sense with our equations, we say the empty set. If you guys write your zeros as a 0 with a line going through it, I would really stop doing that now, because your professors or graders or even teachers, they will mistake that for that 0 for empty set. And so let's do an example. So let's start off with a really easy one. 3x plus 1. Oops, it looks like I forgot to add something here. This is just an expression. Well, let's put it equal to 7. Okay. So when we're solving equations, what is the goal? Well, the goal is to isolate our x terms, meaning we undo PEMDAS. And the whole idea is to get x's by itself. And so that means we want to move this 1 over. How do we move it 1 over? Well, if you see this plus sign here, we're going to want to move it to this side. So instead of +1, we're going -1 on both sides, because that's the rules of algebra. Whatever you do to one side, you must do to another. And if you don't, 3x plus 1 is equal to 7. So until you guys can mentally do this, I recommend writing it out like this. It just organizes your work more. Alright, so on this side, this cancels out. +1 and -1 cancels out. So that just leaves us with 3x. And we're going to say it's equal to 6. Now we just want a single variable of x. We want 1x. Well, how do we do that? Well, we're going to divide by 3. Will give us x. A single number of x. And what's 6 divided by 3? Well, that's 2. In a lot of cases, a lot of teachers will just leave it like this. But once you go into college algebra and higher level math, they will expect you to write in sets. So our set would be 2. Let's do another one. B. 3 times the quantity of x plus 7 is equal to 4. Same goal. We want to isolate a single number of x. What we're going to do now is we're going to divide by 3 on both sides. Why do we do that? Well, it's because it's 3 times this quantity of x plus 7. And to get x plus 7 by itself, we need to divide by 3 to get rid of this 3. And by the rules of algebra, we do it on both sides. So these 3's cancel out, and so we get x plus 7, which results in x plus 7 is going to be equal to 4 over 3. You don't really want to divide out now. If you round now, or if you get repeating decimals, it's going to force you to round. And it's going to basically create rounding error, and you're going to get a slightly different result. So for accuracy, we wait until the end to convert this fraction to a decimal. So now we have x plus 7 is equal to 4 over 3. We want to isolate x now. So we have x plus 7 is equal to 4 over 3. So to undo this plus, like before, we're going to subtract it. That leaves us with x is equal to 4 over 3 minus 7. And so assuming you took your arithmetic and you know how to deal with fractions, we're going to get the least common denominator. So we're going to blow through this real quick. So we have 7 over 1 is going to be, and so we want a 3 on both sides, so we're going to multiply by 3 over 3. And the reason being is to get a 3 on this bottom, 1 and 3 have 3 in common. This has 1 in common. So to make this a 3, we're going to multiply this by 3, but to do that, we need to multiply the top by 3. So we have 4 over 3 minus 7 times 3 is 21 over 3. And so simplifying this down now, we get x is going to be equal to minus 17 over 3, right, in set notations, which is going to be more helpful in the long run. In my opinion, at least, 17 over 3. So let's do one last example. 9x plus 9 is equal to 3x plus 3. We want to get one variable of x on one side and numbers on another. Same idea as before. So what we're going to do is we are going to subtract 3 from both sides. Subtract 9 from both sides. 9x minus 3x. What does that give us? Well, it gives us 6x. And the 9's cancel out on this side. Leaves us with equal. 3x's cancel out on this side. And 7 minus 9 is minus 2. Now what we're going to do is we are going to divide by 6, and x is equal to minus 2 over 6. And if you actually look at this, 2 and 6 have 2 in common. This cancels out to, this reduces, not cancels. This reduces down to minus 1 over 3. And we say it's going to be equal to x, or in set notation, Just a quick recap. In a previous video, we talked about single variable and multivariable equations. Just a brief mention. And then we also defined a bunch of different equations, or types that we will study throughout algebra. There are the Algebra 1 and Algebra 2 playlists on this channel. But we just mentioned them. We didn't really go in depth about them. And within that video, I said the easiest kind to deal with is polynomials. And what a polynomial is we have terms consisting of numbers and variables, a mixture of both, raised to powers, and we just add them up and we put them in descending order of powers. The simplest case for a polynomial is a linear polynomial, which is a polynomial of power 1. And we also said the easiest equation to deal with in this video is a single variable equation. When we're solving these equations, we are undoing the order of operations. So when we're adding, we subtract. When we divide, we multiply. And vice versa. With that being said, guys, I'll see you guys next video.